Hello friends, today I will discuss the numerical problems on mesh analysis. So let me take a problem like this. So here is a 7-volt supply connected to a 1 ohm, 2 ohm resistor, 3 ohm resistor, 1 ohm resistor, 2 ohm resistor, and here 6-volt supply is also there like this. So what he wants is what is the current flowing in the 3 ohm resistor. So to solve this type of problem, first of all, we have to designate loops. So means we have to identify the loops with numbers, and then loop currents we have to assign, and after that we have to give the polarity for each element in the circuit with respect to the current flowing in each loop. Then we write the loop equations. So look at this, we have to remember one thing. So there are two terms that we often identify or we found while writing the equations here. So if we get the negative polarity across a element first in the assumed current direction, then positive terminal, positive polarity, then we call that as voltage rise, and that element will get the positive sign. Whereas if we find the polarity of the element is first positive and next negative with respect to the assumed current direction, then we call as, it's a polarity, we take that as negative. So then, so as I said, this is the circuit which is redrawn here, and then this, I assume this is loop 1, this is loop 2, and this is loop 3. For loop 1, the current flowing is I1. For loop 2, current flowing is I2. For loop 3, the current flowing is I3 in this direction. This is assumed direction. So once we have done this, so we have to give the polarity across each element voltage. So to get that, we have to take one loop at a time, then give the polarity for elements. So then go to this another loop, again follow the same steps, give the polarity for all elements in that loop. Similarly, another loop. So let me take the first loop. This is the first loop, and the current flowing is I1 and flowing in the clockwise direction, whereas in the second loop the current is flowing in the clockwise direction, and in the third loop also it is flowing in the clockwise direction. So because we want to write the loop equation for loop 1, so first of all, for all the loops we have to find what is the polarity across each element. So polarity means voltage across the element, that is the meaning of that. So let us say first we take first element 1 ohm. So here current is entering the 1 ohm, I1 is entering, then leaving. So we call that entering current as positive terminal, leaving terminal as negative. So next there is another element in loop 1, that is 2 ohm resistor. First I1 is entering here, then leaving. So first entering we call that as positive and leaving that as negative. And whereas here there is a voltage source, but voltage source polarity do not change with respect to current direction chosen. Then here we have the 7 ohm volts source, and its polarity is also fixed. It will not change its polarity with the assumed current direction. This is always negative bottom plate, and top plate is positive polarity. Similarly for loop 2 also, this is the I2 direction. So we start at one element. So let us say at 2 ohms. So first current is entering. So we say that is positive terminal. Leaving the 2 ohm resistor we call as negative. Then current 3 ohms is entering here. So I2 is entering the 3 ohm resistor. So we call that as positive and leaving the terminal as negative. So similarly here 1 ohm resistor is there. First I3 enters here. So this is positive and leaving terminal of the 1 ohm we call that as negative. So similarly for loop 3 also we start at one element, say let us say 1 ohm resistor. So I3 is entering here, so we call this is positive terminal, and leaving the 1 ohm resistor we call as negative polarity. So then you have the 6 volt supply, its polarity do not change, it's always negative and this is always positive. And then come to here, this is the 2 ohm resistor and I3 is flowing and first enters the 2 ohm resistor, so we call this as plus terminal, and leaving the 2 ohm resistor we call as negative terminal. So after that again current enters the 3 ohm resistor here, so this is positive first, and because it is leaving 3 ohm resistor it will get the negative polarity here. So we have done, means we have identified the all the loops, and we also assign the loop currents, and also we assign the voltage polarity across each element in each loop. Once this is done, so then we can write the loop equations for individual loops. So let us take for loop 1, what is the loop equation or KVL equation. We start at some point. So in this direction, that is in the I1 direction, first we are getting negative terminal of the supply, then positive. So means going from negative to positive, going from negative to positive in the assumed current direction, we call that as voltage rise, and that element or that voltage will get the positive sign. So we write here positive value 7 plus 7. So next, in this loop 1 there is a 1 ohm resistor here, so we have the polarity here plus first next negative, so it is plus first next negative means it is voltage drop, and voltage drop will get the negative sign. So minus 1, that is R value, into what are the currents flowing, because we are writing loop 1 current, we assume the I1 is more than the neighboring loop current, so we write first I1, 1 into I1, and there is another current also flowing I2, but flowing from bottom to top in the 1 ohm resistor. So mean in the opposite direction of the I1. So we write minus I2, means it is opposite sign of that I1. So that is why we write here I1 minus I2. So then we have another element called 2 ohm resistor here. So polarity with respect to the I1 we already given, that is plus first next negative, means it is a voltage drop. First plus next negative means voltage drop. Voltage drop means it will get the negative sign. So if you look at this loop 1, minus 2 we write first because it is a voltage drop, into what is the current flowing. For loop 1 we assume I1 is more than neighboring current. So I1. So next there is another current also flowing, that is called I3, but it's flowing in the opposite direction as that of the I1. So this I3 will get the opposite sign of I1, that is minus. So I1 minus I3. Then we have another element called voltage source here, plus first next negative. The polarity of the voltage source does not change with the assumed current direction. So going from positive to negative means going from positive to negative is nothing but again it's a voltage drop. So we write here in the loop 1 minus 6 is equal to 0, means loop 1 equation we have written. So now we simplify that equation. So once we simplify that, we get minus 3I1 plus I2 plus 2I3 is equal to minus 1. We call that is equation 1 or loop 1 equation. Next, similarly go to the loop 2. This is the loop 2. So we start at some point. This is the 1 ohm resistor. We start here. So we are writing the loop 2 equation, means I2 current will be more than the other loop currents. So we write here I2, and first we are getting plus next negative, means it will become plus to minus in the assumed current direction, means we call that as voltage drop, and voltage drop will get the negative sign. So minus 1 into current flowing in that. So minus 1. Second loop means I2 first comes, then I1 is also flowing but flowing in the opposite direction. So we write here minus I1. So minus 1 into I2 minus I1. So next we have another element. So polarity already fixed, that is plus here minus here. So plus going from positive to negative in the assumed current direction, we call that as voltage drop. So we write minus 2. So what is the current flowing? There is only one current, that is I2. So we write minus 2 I2. Next in the second loop we have another element called the 3 ohms, and polarity is already fixed with respect to this loop 2 current plus here next negative. So going in the assumed current direction, getting positive next negative means it becomes voltage drop. So we keep minus sign for the 3 minus 3 into current flowing, because we are writing loop 2 equation, so we assume loop 2 current is more than the other loop current, so we write first minus 3 into I2. So what is the other current flowing here? I3 is flowing, but I3 direction is opposite to that of the I2, so we have to give the minus sign to the I3. That is why we have written here I2 minus I3. So this is over, this is also over, this is also over, so there is no source, so we write put simply equal to 0, and then you simplify this equation further, then we get minus I1 minus 6I2 plus 3I3 is equal to 0. This we call as loop 2 equation. Similarly, we write the loop 3 equation. So loop 3 equation is nothing but like this. So start at one point, this is say 1 ohm. So here what is the current flowing? It is I3. So what is the sign that we are getting? Plus first, next negative, means minus 1 into current flowing is I3. So that is why we have written here minus 1 into I3, means simply minus I3. Then we have another element here. So in the assumed current direction I3, first we are getting negative terminal, next positive, means going from negative to positive is called voltage rise, and voltage rise will get the positive sign. So we write simply plus 6 here. Next we have another element here, 2 ohm resistor. I3 enters here, leaving here. So getting first positive, next negative means voltage drop. Voltage drop will get the negative sign. So minus 2 into what is the current flowing in this. So because we are writing the loop 3 equation, so we assume I3 is more than the other loop current. So I3 A minus. So here there is another current also flowing here. That is I2 is also flowing, but I2 is flowing in the opposite direction that of the I3. So we write minus I2 here. Minus 3 into I3 minus I2 is equal to 0. So similarly, after simplification of this equation, we get 2I1 plus 3I2 minus 6I3 is equal to 6. So we say that is equation 3. So we have the loop 1, loop 2, loop 3 equations. So put them in the matrix form like this. So that is minus 3, 1, 2, minus 1, 6, 3, 2, 3, minus 6 multiplied by with the current matrix, that is I1, I2, I3, and right side we are getting minus 1, 0, 6, minus 1, 0, 6. So once this is formed, using the Cramer's rule, we can get what is I1, what is I2, and what is I3. So to get I1, so what we should do is, in this matrix, replace the first column with the right hand side matrix. So remove this, replace that with this matrix, that is minus 1, 0, 6, and the rest of the elements will remain same like this. Then divide this with the matrix, this matrix, means you keep this matrix as it is here. Minus 3, 1, 2, minus 1, minus 6, 3, 2, 3, minus 6. Once we simplify this, we get 3 amperes as the I1 current. So similarly, to get I2, what we should do is replace this second column with the right hand side matrix. Then divide that with the original matrix, that is this, means this. So once we divide that and simplify that, we get what is called I2. Similarly, to get I3, so replace this third column with the right hand side matrix and divide with the original matrix determinant, that is this. So once we do that, we get I2 and I3 as I2 is 2 amperes, I3 is 3 amperes. So what we want is, what is the 1 ohm current. 1 ohm current means, look at this. There are two currents flowing, I1 and I2 flowing. So both are opposing each other. So I1 minus I2. So I1 is 3 amperes, I2 is 2 amperes. So 3 minus 2 we get. So that is 1 ampere. Similarly, 2 ohm current is nothing but, this is 2 ohm current. So here the current flowing is I2, and I2 is that we are getting here 2 amperes, which already calculated. Similarly, for 3 ohms also we can find what is the current flowing here. So the difference of I3 and I2 is nothing but the 3 ohms current. That is I2 minus I3 or I3 minus I2, we get 1 ampere magnitude.